In section 5, we're going to look at two other ways to prove triangles congruent. So if you remember in section 4, we looked at side, 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 and side, angle, side. In section 5, we're going to look at angle, side, angle, and angle, angle, side. These are going to be the next two ways that we're going to prove triangles congruent. The first one that we're going to look at is angle, side, angle. So kind of like how we had an included angle when we looked at side, angle, side, we now get what is called an included side because it is a side located between two consecutive angles of our triangle. So that's the method that we're going to try and use in this example. We're going to try and prove this triangle congruent by angle, side, angle. I'm just going to write it up there so we can see that. This given doesn't tell us anything specifically is congruent other than angle PSQ, it's this one, and angle RSQ, which is that one. We need to come up with a side and another angle. The side that we're going to use is the one that's part of both. We're going to say SQ is congruent to SQ by the reflexive property. That takes care of our one side length that we need. Now we need to come up with another angle. And the angle is going to be based off of the one that's in our given. Angle PQR. It tells us that QS bisects that angle. So I'm going to look for angle PQR. That's right here. It tells us that QS bisects that angle. So that means this angle should be congruent to that angle. So the top angle we're going to say is angle PQS. Angle PQS is congruent to angle SQR. And the reason that we're going to use is based off of a bisector. If you want to put angle bisector, you certainly may. As you can see, we now have our angle side angle relationship, angle side angle, and angle side angle within both triangles, which means that our triangles are now congruent. So we're going to say triangle PQS, triangle PQS is congruent to triangle RQS by angle side angle.